here is what we're doing today. By the way, this whole chapter is about inequalities. So we're going to be talking about inequalities. All right, so this first section is solving inequalities by addition and subtraction. So before I actually start with the inequalities, I want to review a little bit about equations, okay? So I'm going to scroll down to the end of the whole list just so I can get some free space so I can do something with you. So just watch right now. Don't write anything down. And ignore all this up here, okay? I'll just blow it up a little bit. Okay, so if you remember solving equations, so we had x plus 7 equals 10. I'm not sure if you guys remember it. It was so long ago, I don't remember if I did it anyway. There was I used like a teeter-totter as my base, right? So this is a balanced equation. So it's an equal teeter-totter. So everything's balanced. So the left side is equal to the right side. Now that means that if I do something to the left side, I have to do the exact same thing to the other side in order to maintain that equilibrium, right? So in this case, I want to get x by itself, so I would subtract 7 from both sides. But if I take something off the left side and I don't do something to the right side, that equals, it is no longer valid, right? Because now they're not equal anymore, because I subtracted 7 from the left side, so now it's less. I've got less over there. It's like this weighted thing, right? So I would have to subtract 7 from the other side. If I subtract 7 from both sides, then what happens is it maintains its equality. Okay? Now why am I bringing that up? Because that was like months ago. Well, what about inequalities? Let's say I have x plus 7 is less than 10. So whatever x is, we know that when we add it to 7, that number is going to be less than 10. Now, if this were a teeter-totter, what would it look like? Right? This guy's heavier. This guy right here is heavier, pushing down harder than this guy. This guy's sitting in the air, right? What if I subtract 7 from both sides? What happens? Does anything change? It maintains that inequality, right? So just like an equation, if we do the same thing to both sides, it doesn't change the value of the inequality. So if I add something to both sides or we subtract something to both sides, we still have that same inequality. Now, why is this important? Let's go back up to our actual work. Sorry, hopefully I'm not like making anybody sick. Okay. So, the addition property of inequalities, right here, says if the same number is added to each side of a true inequality, the resulting inequality is also true. Okay, so it's basically saying we have that teeter-totter. If I add something to both sides, it still keeps that inequality intact. So if A is greater than B, then if I add C to both sides, A plus C is still going to be greater than B plus C. If A is less than B, and I add C to both sides, then A plus C is still less than B plus C. Okay, so that is what our property is that we're going to be dealing with today. We're going to be dealing with the addition property of inequalities, which we just dealt with, or we just showed. We're going to be dealing with the subtraction property of inequalities. Okay, now, a little bit of review though first, because we're going to be graphing a bunch of these. It says graph x is greater than -3. Now, when we're graphing an inequality, what we're basically saying is we have a number line of numbers. How many numbers are on the number line? Infinite number of numbers are on a number line. What we're saying is if we have to graph x is greater than -3, half of the numbers, half of that infinity, is going to be solutions. The other half are going to be non-solutions. What's the cutoff number that tells us where the break is between solutions and non-solutions? I'm on this one right here, letter A. -3. So if I go to -3 right here, I have all the numbers to the left, I have all the numbers to the right. Which one of those numbers actually fits that, makes that true? The numbers on the left or the numbers on the right? The right. So I'm going to take those guys off. I would do this, but at -3, I have two choices. I can make an open circle or I can make a closed dot. An open circle says that -3 does not fit into our solution set. A closed dot says, yeah, -3 will work. This says x is greater than -3. Is -3 greater than -3? No. So that means I have an open circle. All right, letter B says x is less than or equal to 2. Okay, so what's my cutoff number? 2. So I'm going to do this. Now, are my solutions going to go to the left or to the right? So if I plugged 1 in, is that a solution? Is 1 less than or equal to 2? Yes. Is 3 less than or equal to 2?
No.
No. So I'm not going towards 3, I'm going towards 1. Now we have to ask ourselves, does 2 fit? Is 2 less than or equal to 2? Yes. And that would be a closed dot because we have to include 2. Do you guys remember this stuff? Kind of, I know it was a long time ago. All right, so the last one has them in a different order. It has -4 is greater than or equal to x. We're going to still treat it the same way. So -4 is our cutoff. Now I need to determine if I'm going to go left towards -5 or right towards -3. So if I put -5 in here, is -4 greater than or equal to x, or -5? Yeah, so I need to go towards -5. And then I have to ask myself, is -4 greater than or equal to -4? Yes. What's the key on that whole thing that tells you whether it's a closed dot or an open circle? The line on the bottom. If it has a line on the bottom, it's filled in. If it doesn't have a line underneath that symbol, it's open. Okay, so this was all review. I know review in these days is a little hard because we've got so much being thrown at us with just regular living our lives that it's hard to remember everything that happened in math. But we are going to be using it again, which is the hard part about math, right? If you struggle in one part, you know it's going to show up later on, right? It just happens because it's math. You know this is called Algebra 1. That's because Algebra 2 is coming in 2 years, okay? So it's going to happen. You're going to get some more of this. All right, so let's take a look at this, this problem right here. We have 22 is greater than m minus 8. Guess what? Our goal is still the same as it was when it was an equation. So our goal is to get m by itself. Well, m is connected to the 8. I have to get rid of the 8. How is the 8 connected? What operation? Subtraction. And so to get rid of it, we have to do the opposite inverse operation, which is addition. So we're going to add 8. But remember that teeter-totter? If we do something to one side, we have to do it to the other. Otherwise, it takes that teeter-totter and makes it all out of whack. So we're going to add 8 to both sides. So 22 plus 8 is 30. Is greater than m, that goes away. Now, unfortunately, my graph is not scaled to our numbers, right? So let's see, what can I do to change this? Can I make them like 10, 20, 30, 40? I could do that, right? So instead of 1, 2, 3, I'm going to do 10, 20, 30. So I'm just going to think of my 3 as a 30. Sound good? Now my decision is left or right. I'm going to choose an easy one on the left. I've got 0. On the right, I have 40. Right, because we changed them to 10, 20, 30, 40. So is 30 greater than 0? Yes. So that means I want to go towards the 0. There's no line underneath my symbol, so it's open. Now, if you did really well with solving one-step equations with addition and subtraction, then you should do really well with solving inequalities using addition and subtraction, because we're doing the exact same thing. The only added part to it is we have to graph it after it's done. Okay, so if we go up here to example 1, x minus 12 is greater than or equal to 8. We karate chop. We want to get x by itself. So what are we going to do, Mason, to get x by itself?
Subtract 12.
Are you sure we're going to
Add 12.
add 12? We're going to add 12 because we're going to do the opposite. So we add 12 here, which means we have to add 12 over here. So we have x is, oh, I can't even see it. That karate chopping thing got in the way. Okay, it's greater than or equal to. Right, so x is greater than or equal to 20. All right, you know what? Let's just ignore this line and I'll just do my own. Here's 20. To the left of 20 is 19. To the right of 20 is 21. Which one makes this true? 19 or 21? Lauren? Is 19 greater than or equal to 20, or is 21 greater than or equal? Does the alligator eat the bigger number when it's 19 or 21? 21. So here's 20. I got to go towards 21. Open circle, closed dot. Closed. All right. Are we getting the hang of this one? Let's go to the next one then. Let's skip D. All right, D minus 14. All right, now let's go here. And we have the subtraction property of inequalities. This is the exact same thing, only when you take something off of both sides, it maintains the inequality. So if you look, it says, if A is greater than B, then A minus C is still greater than B minus C. And if A is less than B, then when you add C to both, or subtract C from both sides, A minus C is still less than B minus C. So, same process, different operation, right? So, we have P plus 8 is less than or equal to 18. What should I do to get P by itself? Garrett, what should I do to get P by itself? Garrett? Garrett?
Should take away 8?
Yeah. Absolutely. So we're going to subtract 8 from both sides. And when we do that, we get P is less than or equal to 10. All right, now we can actually use this graph that I had. 10 is on our graph. Here's 10. Is 9 going to make that true, or is 11 going to make that true? Let's. Maddie, which one is going to make that true? What's that?
9.
9. So let's go to the left. Is it going to be an open circle or a closed dot, Sophie? Sophia?
Closed.
Closed, absolutely. Okay, so here's what we have for an answer. P is less than or equal to 10, and my graph. Okay, so let's try. Oh, there's like randoms. Okay, so let's just do these two and then we'll go to the word problems. How's that? X plus 23 is less than 14. Grady, what should I do?
Brady?
Grady, G.
Okay.
What should I do to get X by itself?
Subtract 23.
Yep, we're going to subtract 23. Okay, so we have X is less than, 14 minus 23. Anybody know what that is? Negative 9. So I am going to separate or cut my graph in half at negative 9. And now I have to determine if it's going to go left or right. Is it going to go towards negative 10 or is it going to go towards negative 8? Cooper, which one do you think? Okay. Is the alligator eating the bigger number when you have negative 8 in for X? Remember, when they're negative, it's opposite. Like, I'd rather be $8 in the hole than $9 in the hole. All right, so I'll put this up there. One of those is true, one of those is not true. Yeah, yep, so we're gonna go left. And because it's a less than and not a less than or equal to, Malachi, is it gonna be open or closed? Okay, well, it's less than, it does not have to have the equal sign underneath it. Is negative 9 less than negative 9? Nope, so that means it's open. Okay, now the next one's a little weird. What makes this one weird? This is open to anybody. Anybody can answer, at home or in person. What makes this one a weird one? It has multiplication because it's got that 10n and a 9n. Don't worry, we don't multiply yet. I haven't taught that to you.
There's variables on both sides.
Variables on both sides. So to solve this, we want to get the variables on the same side. So instead of throwing over the plain number, we're going to throw over the variable. So I'm going to take this 9n and I'm going to move it over here. How do I make it go to the other side? Okay, Brady, you can take this one if you want.
Subtract 9n.
Yes, we're going to subtract 9n. When we subtract 9n, what's 10n minus 9n? 1n. So don't forget that minus sign is greater than 1, it becomes a -1. -1 is less than 1n, which happens to be just n. I told you you didn't have to do anything with that multiplication or division yet. Okay, so we've got it solved for n, we can go ahead and graph. So here's -1. I've got 0, and I've got -2. So -1 is less than 0, or -1 is less than -2. Which one of those satisfies our alligator? 0 does. So we're going to go towards 0, which is going to the right. And there's no equal sign, so it's going to be open. Okay, so you guys, when you have variables on both sides, you want to get the variable to one side. Please take the smaller of the variables over to the larger of the variables, because I haven't taught you what to do if you go the other way yet. Not until tomorrow. Okay, so let's go to our word problems, and then we're done. Felipe needs, for the temperature of his leopard gecko's basking spot, to be at least 82 degrees Fahrenheit. Currently, the basking spot is 62.5 degrees. How much warmer does the basking spot need to be? Okay, so right now it's 62.5 degrees, right? We need to add some heat in order to get it to be at least 82 degrees. What does that look like in symbol form? Does it look like this, like this, like this, or like this?
The greater than sign with an equals under it.
Right, it has to be greater than or equal to 82. Okay? This is the absolute lowest number it could be in order for that gecko to be happy or alive, one of the two. So now we have to solve for h. What should I do to solve for h? Minus 62.5 from both sides. And I think when we do that, I want to say it's 19.5 degrees. So that is how much more heat needs to happen in order for that gecko to bask in his spot. All right, so one last problem. Sanjay has $65 to spend at the mall. He bought a t-shirt for $18 and a belt for $14, and now he wants to buy a pair of jeans. How much can he spend? So he had $18 that he spent already, plus the $14 that he spent already, plus how much he can spend on his jeans. And all he has is $65. So what would I do? What symbol would I put there? Do you think it has to equal 60, less than or equal to $65? And then we would add these together, subtract from 65. What is that, 32? subtract from the 65, and we have, he can spend up to $33 on his jeans. Okay? That is it. Here's your homework.